Hello and welcome back to Hot Topics, the DuraSpace Community Webinar Series. My name is Christy Searle and I will be facilitating today's session. Just a reminder that the chat window is available at the left side of your screen. At the end of the presentation today, we will be taking questions from our audience and we'll ask you to post your questions in the chat window at that time. We're pleased to have you with us today as we conclude our VIVO plus Share Hot Topics webinar series. Today we are joined by Erin Braswell and the curator of this series, Rick Johnson. Together they will present today's webinar, How to Get Started Tracking Scholarly Activity with VIVO and Share. I will turn it over to Erin to get us started today.
Hello, everybody. My name is Erin. I'm a developer at the Center for Open Science. And Center for Open Science has been working with Share for a while, for a very long time. We're very happy to be technology partners with Share. And just a little bit of background. I know this is the third in this series, but so Share is an initiative. It's led by ARL, the Association of Research Libraries, and with the technology partners, Center for Open Science, which is where I am, with the support of the Association of American Universities and the Association of Public Land-Grant Universities. And we've also gotten generous funding from the Institute of Museum and Library Services, as well as the Alfred P. Sloan Foundation. And so COS has been working with Share from the very beginning. When we started off, we just had 20 metadata providers, and we've grown to, right on Friday, we released a new release, and now we have 104 metadata providers to Share. So I did a little more background about the mission of Share. So Share is a higher education initiative, and we're aiming to maximize research impact by making research widely available across a whole wide range of sources. And so we really value openness and transparency. We hope that all of our products are really open, and we want to make the process as transparent as possible. And we really want to welcome the input from interested stakeholders and community members. And so it's all of our code is open source, and hopefully all of our process is made clear and open. We also value international interoperability. So we are a North American initiative, but we know that that's only a very small portion of the research effort across the globe. So we're always looking for opportunities to develop and adopt standards and practices that will help knit the world's research together into a more cohesive, accessible whole. And we hope to be a part of that process. And we also really focus on simple and pragmatic solutions. So we realize that challenges are really complex, and a lot of solutions are going to be far from perfect. But we want to start with something really simple and accessible to get started meeting these really large goals. So the second part of that mission is we are building a free open data set. And by data set and by research, we don't mean the actual research output. We mean metadata about that research. So it's not re-hosting all of that research data. It is gathering metadata or information about that research, including like title, contributors, a link back to the original, and as much metadata as we can gather from each provider, really. And that giant bucket of metadata is the free open data set that tries to capture information about research and activities across their entire life cycle. And we do this by the most simple solution for right now. We pull already existing streams of metadata for the most part. And we also gather metadata from a push API, which lets people send us their pre-formatted metadata, which I'll get to in a little bit. So we're trying to capture information about metadata across all the different aspects of research, including manuscripts or preprints, grant and award information, data analysis scripts, and related studies or replications. And so we don't want to limit our interest to just the published report or even just the published data, because we'll miss important contextual information that can be essential in understanding the published report in the first place and building on it and finding collaborators and replicating that data. So I said that we gather metadata, and that metadata comes in a lot of different formats. And so the new knowledge and understanding that's out there on the web about research is increasingly diverse in format and output, especially in the digital era. And so scholarly communication is highly distributed. And so we are going to those sources in their various forms and collecting the information and normalizing it into one open access point that people can get to. So right now we have over 104 providers, and they're in a whole bunch of different variety of formats. And so in the previous webinars, we've heard more about the mission and the goals of SHARE. And so today I'm going to be talking about the specifics of exactly how we process the metadata, how we normalize it, and then how we make the contents available again to researchers. Since I'm a developer, I've worked on the technical back-end processing, and people might be interested in how that's done and the ways that you can access it and find information about how to access it. So another important point is that if you would like to become a provider to SHARE, this form that you would get at osf.io/share/registration is a very simple form. You fill out your name, the place that we can access your research metadata, as well as any documentation that we should be aware of. And we will take a look at that documentation and see if we can, we'll add it to the queue and see if we can add your institution as a research provider to SHARE. And if we have any questions about it, we can get back to you later. So going on to the fact that SHARE, we strive to be as open as possible. We use a variety of open source projects on our metadata processing pipeline, and we call that ScrapeAI. Because we are scraping data and also grabbing using APIs. We're actually not scraping data yet, but we could possibly when we start enhancing our metadata. And so it's built using a variety of really great open source projects. So the main meat of the processing pipeline is built using Python, which has a fantastic open source community. They're very welcoming. Lots of great projects are built using Python. Along with a variety of other tools. So we gather and process the metadata using RabbitMQ and Celery, and those are great for scalable asynchronous processing so that we can continue to grow along with the data sources, the number of data sources we harvest. We store the data using the databases Cassandra and Postgres, and we expose the raw and normalized metadata that we've gathered using Django REST framework powered API, as well as Elasticsearch, which is really powerful and really great for using to search across the entire data set, and also to get aggregations about metrics across all of the data set and all of the fields that we collect among all of the different sources. So first, a little bit about how the shared data processing pipeline works. This is if we harvest from your source. So what happens is the first thing is we access the document via an API, via the provider's original source. And what happens next is we process and we save both the request and the response. We process the raw data and we normalize the data. So that process, request, and response step, we archive both the initial requests that we made and we archive the response that we got from that initial request. And we do that to speed up any future reprocessing so we don't have to over-request any data from the source repositories when we need to go back and make adjustments and evolve this data as we continue. And it reduces server load and makes processing a little more scalable so that we can do this massive reprocessing without doing too much re-requesting. And that raw data gets processed in a variety of different ways. So that raw data is saved in Postgres and other forms of storage like Cassandra or local storage, or if in the future we add other storage inputs, it's all very modular. We can just plug in a new version. If we wanted to add new features, we can add in a new storage set. And then on top of that storage, we have web access that people can go and access that raw data as well from the web and access it via an API, which we'll talk about in a bit later. So, and then that normalized data is also processed. So it's brought in using a variety of different schemas and put into one share schema, which is what we have now. But again, that's also very flexible. As the community continues to evolve what it needs in a unified research metadata schema, we can continue to evolve the share schema along with it. And that normalized data is accessible both through a web API right now and also via Postgres, which is more accessing the raw and normalized documents. And for really advanced search and aggregation capabilities, we expose it using a tool called Elasticsearch. And you can send any standard Elasticsearch query to this endpoint and it will return you the information. We'll get into a little bit more of that later. So another way that we get metadata from our providers is we have a push API. And what that is it allows any repository to send us pre-formatted data. So if you want to skip the queue right away, you can push us pre-formatted data that meets the current share schema. And that will get put into a somewhat of a holding area until we're ready to pull it in, and then that will be harvested along with the other content. Right now, we have one in the pipeline. We have one official provider who is using these push capabilities, Scholarsphere at University of Pennsylvania, which has over 700 documents in share right now that they update on their end and then send us along instead of us going to their repository and harvesting the data on a daily basis and going through that normal processing pipeline. They just send us new data whenever they have it, and that gets added to share. So here is where you can access documentation on that push API. There's most of our documentation for share is hosted on the Open Science Framework. You can find it here. You can navigate around, find different information about what kinds of things you're looking for, including the schema, details for the push API, details for how to access share data in general, which I'll talk about a little more in depth right now. So I've been saying API a lot, and so I wanted to give you a little bit of background of what that is in case you're unfamiliar with the term, and that stands for Application Programming Interface. And all that is a way for services on the web to talk to each other. And the interface really is the key in the API. So APIs have many different interfaces, and they have many different ways to access the data. And so that's what documentation is for, and that's what presentations somewhat like this one are for. It's just so that programmers and developers and people who are interested can understand the interface, so then you can get the most maximum power out of it. So APIs are literally just a way for processes on the web to talk to each other. And anyone can access these APIs and get information back from them. And so one very, very simple access point on top of the share API is osf.io/share. And this was a way for people to right away get into the share API and do some very basic searches that will show you some information about the information that's in share. So this web page is built only on top of using the share API. So anyone can use the share API to build something like this, along with all of the very powerful features that come along with the API. So here is a quick example of what comes back from this share search page. It'll show you all of the events in a row, and if you're interested in getting an RSS feed of the events that show up in your search, you can go ahead and click that little button next to the magnifying glass, and that will give you an RSS feed of all of the new results that come up because of your search. And you can also use this search page to narrow down results by provider, by contributor, by data tags if we have them. So this search page is built on top of that share API that I'll get into a little more detail now. So this is the access point for our raw and normalized documents. It's literally just a layer directly on top of the database. So by going to this URL and accessing this URL, you can directly gain access to the raw document that we harvest depending on the format that it's in. Usually it's in XML, but a lot of our documents we harvest are in JSON, as well as information about when the documents were harvested, a unique document identifier, as well as the source that the document originally came from. And that document ID, as well combined with the unique document identifier from the source, as well as the source that the original document came from, can be combined together to make a unique key for that document that we harvest. And so using this API, you can find both the raw documents and the normalized documents that we harvest from each of the sources. And the Elasticsearch endpoint, which you can access right here, is actually a little bit more powerful. You can do a lot more searching on this API. You can do a lot more filtering and queries, and all of that is documented on the Open Science Framework. I'll have a link to that at the very end of the presentation if you're interested. But Elasticsearch, you can send any sort of pre-formatted queries to this endpoint, and it will return you information about those endpoints. And a couple days ago, actually on the 17th, we did a presentation on that went way more in depth. It was about an hour long about how to query the Share API using the different methods. And I'll go over a few of those now. Here's just a little bit of code on how to get started querying that Share API. So this piece of code, very simply, this is using a tool called the Jupyter Notebook, which is just a way to, or it used to be called IPython Notebook, and it's just a very quick way to run some code and then see the results right in your browser. And there's a link to these tutorials at the very end of this presentation so that you can download them yourself, set it up. All of this code is available on GitHub. Download the code, run through the examples that are presented here. So this is just a quick example of what you can do. So this particular piece of code will go to our API, request all of the information about them, about each of our providers, including this particular one is its icon, or its icon representation, as well as its long name, which is our the official name, as well as the short name, which is just the name that we use as a key in the database. So it's a very simplified version of the name of the provider. Just a quick example of what you can do with the Share API. And so this is an example of a really quick example of a type of query that you can send to the Share API. Again, the other webinar that we did goes into way more detail about how to use this, and there's a link to that at the end of this presentation. Didn't want to get too terribly technical for this one, but you can do queries to see what resources have information about sponsorships, or about funding information, or about specific contributor name. And all of these things you can use the Share Elasticsearch API to find out. You can also do something really cool called aggregations, which are just requests across the entirety of the Share dataset. So this particular aggregation, which looks a little bit complicated, but there are tools, actually, we've developed a Python library to make querying the Share API a little bit easier, which there are links to in the documentation. So this particular query, when sent to the Share API, will return information about documents that do not have a description, or an abstract is what some people might call it. So sending this particular query to the Share API will return information about what documents in the shared dataset do not have a description. And this is something like what the Share API would return to you. This has been formatted a little bit, but just very basic statistics about each of our sources and how many of those sources don't have one of the particular fields in the Share schema. And description is just one example. You can also do this query for sponsor information, or for award information and all of the things that are included in the share schema. Elasticsearch has that information across the entirety of the share dataset. And I think at this point, Rick is going to get in a little bit into the VIVO harvester code that has been written to hopefully connect Share and VIVO. We have all of the code in place. We're waiting for a few more credentials, but we're really excited that we'll be able to connect VIVO access points to Share. And I will pass.
Great, thanks, Erin. And I apologize as unfortunately our second speaker that was billed for today, Alexander Garcia Castro, had to cancel last minute. And unfortunately, that was unavoidable for him. So I have jumped in last minute to do my best here to give a quick overview, very quick, much quicker than Alexander would have done, of what is happening with the VIVO harvester code and how that works. So I figured, since I did not write the code myself, that I would focus primarily on how any of yourselves as institutions could take this and become a VIVO data provider for Share. So jumping in, what we're looking at here, looking at the VIVO harvester code, what is circled there is the very top of the harvester class, and the link is at the bottom of the slides there, where essentially for any data provider for Share, whether it is VIVO or repository or anything else, what Erin has described, what typically happens is there is a harvester created for that data provider. And in this case, for VIVO, Alexander was the author of this VIVO harvester that is lined up to be used for the University of Florida. And because it was created in such a way that should work really for any VIVO instance, the main idea here is that there's really just a little bit that any one institution would have to do to have their VIVO plugin to Share. So what is circled at the top of this page here is a section block that highlights the portion of the VIVO harvester code that where it has things like the base URL and the query endpoint, username, password. So really all it is just a matter of where should Share point to harvest the code, and username and password to have permission to do so. So it's really not a whole lot of extra work to get that done from the VIVO instance side. And if I'll go to the next slide here, taking a look at where this is set. So these are settings that are really separate from that harvester code that we just saw, but essentially it is, again, just these 4 different attributes that need to be filled in. And I will go back a slide very quickly here. So down below, if you do go to the link here, there is quite a bit of code here. And again, I am not planning to get too deep into the details here since I'm jumping in last minute here. But in terms of the VIVO code down below, there are some standard methods that are implemented for harvester, like the method harvest, and within that it has all kinds of pieces where it basically grabs the records from the VIVO, takes them, and then it maps those to that Share schema that Erin was talking about in terms of putting things through that processing pipeline. So a portion of that normalization process is to take all of the records that are coming in from a VIVO record and then essentially plug those into a data structure that then gets sent into Share to get processed and then put in place. And as she mentioned, in terms of waiting on the credentials, that really is just for our first instance for the University of Florida. The main thing that, as I understand it, that is pending there is just to get the credentials sent in, and technically they have the credentials in it, and it's really more of an administrative audit that is pending for that to have permission to say all of the data that would be coming from their VIVO is okay to have public and available coming in to Share. So let me go on one more slide here. More. Okay. So to summarize quickly, the steps to harvest from your VIVO, it really is just to register as a provider, just as I think it was on like slide six that Erin showed. When you go to the shareresearch.org page, there's a place to register as a provider, and then once you do that, the Center for Open Science will contact you, since they're the main technical partner that handles those support requests. And then essentially the Center for Open Science will use the VIVO harvester that is in place to be lined up for University of Florida as a template to create a harvester for your VIVO, and then any credentials that you would have within those attributes, that would then again be separated for a different instance. And because the architecture is set up so that they can create a separate harvester for each institution, it makes it very easy to keep all of that information separate and to make sure that credentials, et cetera, are all pointed appropriately. So then once you set these up, it's really just a matter of test and go. It really is that simple. So that really any institution could contact the Center for Open Science through the Share Register provider now and get things set up to start testing. I think I will pause there, as that was most of what I was able to speak to as a last-minute speaker here. And we'll check in with Christy to see if we want to change over to questions at this point.
Yeah, I think that would be great. So if you are in the audience and have a question, please feel free to type it in the chat window and our presenters will do the best to answer it. Rick and Erin, sorry, thank you so much for presenting to us today. Rick, especially last minute. We do have a question that has already been posted in the chat, if we can go ahead and start with that. The question is, has Share considered calling what it builds a fee open metadata set so it's not confused with the actual research data output?
Yeah, I can take this one, Erin, if you like. So
Sure.
so I would say that's a good point. I think that's one thing that is always kind of a part of the communication process is, by data set, this is what we mean. And yeah, there probably is some wordsmithing that could be done there to reframe that. Well, I'm on the share operations team that looks pretty closely at that kind of language, so I can definitely take that back. In fact, we have a call this afternoon, so I'll be sure to mention that.
Don't be shy. If you have a question, please post it in the chat window. And as we wait for our next question to come in, I did post it above in the chat window, but just to let you guys know that all of today's presentation, as well as the other two that we've already conducted, are available at duraspace.org/hot topics. So we try to include the recording and the presentation slides, so those can be referenced at your convenience. We have a question. Where are the requirements for a non-VIVO repository to submit metadata to Share found?
Yes, I can go ahead and answer that one. Requirements really are only that we gather from each different repository, from each piece of data, the title, the contributors, a link back to the original, as well as the time that it was last updated in that provider, the original source. And that there's links to that on the Share registration page, as well as on the Share documentation and the frequently asked questions. I will post a link to that in the chat window right now. Okay, here we go. So here is a link to the frequently asked questions section. And there is a section on how can I register as a metadata provider. And it has just an overview of what the form will have on it, as well as some basic information we need about your API.
All right. Any last questions before we conclude, giving you 30 minutes back to your day? Okay, we'll wait for Linda's question. Is there an advanced search interface on the development roadmap for Share?
Yes, I believe there is. We have been prototyping one, and I know that there are people in the Share working groups who have been trying to come up with an example of that search interface, or what's the word I'm looking for? A mock-up of what that interface would look like. And as soon as we get that from the Share community, we're excited to build that. You're welcome, Linda.
Erin, Rick, is there anything else you guys would like to add?
Just one quick thing is that all of the code for Share is open source, and so if you're interested in contributing or taking a look at it, you can find it on GitHub at GitHub Center for Open Science /GrayPI, and it's an open source project. We've had a lot of contributors outside of Center for Open Science, which is great. So if you're interested, that's where you can find the code. And here are just some super quick links to some information about this presentation in particular. There's the Share documentation in general, the Share tutorials that I mentioned earlier, if you're interested in really diving deeper into the Share API, as well as a copy of these slides that we saw today.
Right, thank you so much. And Erin, thank you very much for presenting today. And on behalf of DuraSpace, thank you, Rick, for curating this series. We've had 3 very informative, successful webinars that we were very happy to bring to our community. So I would like to thank all of you for attending today. And this concludes our meeting. Thank you very much, and please enjoy the rest of your day.
Thank you all for joining.
Thank you so much. Bye-bye.